In this video I'm going to show you how to solve a radical equation, and we're going to solve it in 3 steps. Step 1, so this process will work for most radical equations that are covered in algebra course. So how do we solve a radical equation? Step 1 will be to isolate a radical. So if your expression has multiple radicals, then just pick one and isolate it. Step 2 will be to raise both sides to the appropriate power. So what does it mean to raise both sides to the appropriate power? That means if you have a cube root, then you probably want to raise both sides to the power 3. Also, this is the step where we want to check for even radicals like square root, fourth root, sixth root. We want to make sure that on the right side of your equation, the number, if there is just a single number, it's not negative. So for example, if you end up with equation like this, then we're not going to raise it to the fourth power because there is no x that will make a fourth root to be negative. So this equation will have no solutions. So this is what we check at step 2. Step 3, after you raise both sides to the appropriate power, you'll end up with equivalent but different in form equation. So if that equation is radical equation, then we'll have to repeat the first 3 steps again. But if that equation is not radical, for example, it could be quadratic equation or any other type, then we'll just solve that equation. So here we're just going to write solve the equivalent equation. And if equivalent equation is radical, then we'll repeat the first 3 steps. And step 4, after you get rid of all the radicals, if there are many, step 4 will be to check for extraneous solution. So this is the plan. Let's go ahead and get started. So in our example, we have 2 radicals in the equation, so just pick one and isolate it. So I'm going to pick the one on the left and just add square root of x plus 4 to both sides to obtain this. So that's step 1. Step 2 will be raise both sides to the appropriate power. Since the right hand side is not a number or is not a negative number, then we just raise both sides to, in this case, appropriate power is 2. So square both sides. This step has to be performed correctly, so the issue is not on the left. The most common mistake is students forget how to square a simple binomial. So to remind you, I'm going to write the formula over here. And if you don't want to remember the formula, just make sure when you square it, you square or you apply multiplication between all of the terms. So a has to be squared, a has to be multiplied by b, then this a has to be multiplied by this b, and then finally b has to be squared. So we end up with the same expression anyway. So whether you remember it or you just do multiplication, you have to arrive to this expression. So in our case, it's going to be 1 squared. So we treat this as a and this as b. So it's going to be 1 squared plus 2 times 1 times radical of x plus 4 plus square root of x plus 4 squared. Alright, so next we simplify. And here we notice that the equivalent equation that we obtained from the original equation is also radical. So to solve it, we have to repeat the first 2 steps, meaning we have to isolate the radical again. So that means we have to subtract x from both sides, 1 and 4. So we obtain this. We can also divide both sides by 2. So that would be the end of step 1. Step 2 will be, again, check that the radical is not equal to a negative number, which it isn't. It's equal to some expression, and we square both sides. So after we square both sides, we end up with this. So this is not a vertical equation anymore, so it should be the equation of the type that we already know how to solve. And in this case, we bring all the variables to one side. So subtract x and subtract 4 from both sides. And what we see is called a quadratic equation, which there are many ways to solve. We're going to go with the easiest approach here, is to factor it and recognize that there are 2 solutions. X could be equal to 0, or x could be equal to 5. And now it is important to remember to check for extraneous solutions. Since we squared both sides and we didn't make sure that what we squared was positive, now we have to perform that check. So let's check x equals 5. At 5 we have square root of 3 times 5 plus 1 minus square root of 5 plus 4 equals 1. It's easy to see that this is true. If we check x equals 0, so we get 3 times 0 plus 1 minus 0 plus 4 equals 1. And it is easy to see that this is not true. So we exclude x equals 0 from the solution set, and the only solution that is left is x equals 5. So the solution set of the radical equation above is x equal 5.